Hello everyone, this is my project presentation for CNT 6805 Network Science and Application. My name is Shishong Jin. Social networks. Nowadays, with the development of network knowledge, we can model many complicated systems into networks, such as biology, social network, computer network. The vertex in the network stand for the different components, and the links stand for the interaction between the different components. And there are many features the community will have in common. The first, the real-world network will more likely have a higher transitivity. We will use the transitivity coefficient to calculate the transitivity. Second, we often use a degree distribution to depict the network. Power law or exponential law will appear in the degree distribution. Most networks have the power law distribution. And for some kind of network, there is a very unique structure called community in the network. For the network, like social network, community detection is very important. It can bring many useful information to the people. Many people in the same community share the same interest and similar characteristics. People will form a community by many relationships like colleague, by family, or by friends. The information about the community can be used to recommend something, like the company called Amazon. He just built its recommendation system on the social network knowledge and information. And when we detect the knowledge community in the network, the biggest challenge is that there is not a universally accepted definition about the community. That is to say, when we use different algorithms to detect the communities in the network, it is very hard to see which algorithm get a more accurate and efficient community. The most acceptable definition about the community is the vertex in the same community has a more dense and close connection and interaction. The vertex between different community has sparse interaction. And this example, here we can see these two verticals, they have a small or very close connection and interactions, so they are in the same community. But these two verticals, they have very long or no interaction or connection, so they just belong to different communities. So we can see here there are three communities here and different centrality. When we detect the community, usually we want to know which verticals it's in the central place, which means who has more influential power over other verticals in the same community. So centrality will become a very important notion. The bigger it is, the more influential the verticals is. So we can use the one who has a higher centrality to spread information or to recommend something to others. Closeness centrality, betweenness centrality, eigenvector centrality is just three important centrality I will introduce later. Closeness centrality. Closeness centrality is the average shortest path length between the node and the other node. Here is equation, and here is a picture. Betweenness centrality is a measure to calculate how often verticals can work as a coordinator between two other nodes which had the smallest path, which means these verticals can put a lot of influence on the communication between different verticals. And here it's an equation, and here is just the picture to show. Eigenvector centrality actually is a bigger version of the degree centrality. Many times verticals have a bigger degree centrality, but not necessarily have a bigger eigenvector centrality. Because when verticals have a link connected to other nodes, some nodes are more important, are more influenced, so these kind of links have more ranks, more credits. That is to say, different links have different importance. Some verticals have few but important links, so they will have big eigenvector centrality but small degree centralities. Now here is just equation to calculate, and here is a picture to show the eigenvector centralities. Detection problems. One of the problems is how to measure and compare the quality of different algorithms. The main reason is when we use the real-world network source, usually we do not have ground truth. which means we do not know the right known answer before we do the community detection. One way to overcome the problem is to use artificial network source. In this way, we could generate as much network data as we wanted. At the same time, the artificial network should be as close as the real world network. In order to get artificial network as close as the real world network, the artificial network should have some common features like the small world, power law distribution, big transitivity. So we can use the information we get from the artificial network and apply it to the real world network. It's very useful. Another way to compare different algorithms in community detection is to use the modularity. This term is introduced by the Newman. They first define a matrix, and we will use P and PG to represent the number I row and number G column. And then we will define the modularity as difference between the saw and expected link function in every community. Then we will sum up all the community. The upper bound to the modularity is 1, but it can get very close when the community is very good. But it will still have some shortcoming, like the community size will influence the modularity. The Gaussian random network get a very big modularity, but it's wrong. It's very misleading. And here just equation to calculate the modularity. The community detection, there is a very important kind of community called hierarchical method, because the final outcome is community tree. And in this big family, there's two big categories. One is bottom up, another is top down. Bottom up, it's every node themselves is a community in the very beginning, and they will continue to combine other nodes to form a big community. Top down is just opposite. It will start from a big community and continue to remove the nodes and link from the big community. The way to decide which two communities to combine or split is according to a kind of distance or similarity function. There are many different kinds of similarity functions, so that would tell different algorithms in that big families apart. Another family is measured based on the optimization. We will have a standard to see this kind of partition is good or bad. In most cases, it is Newman modularity. It's a standard. The principle is like, first we got some partition, maybe random or not. We will choose the one fit the standard best, get rid of the rest ones. Then we will improve this partition. The drawback is modularity is an expensive method because we need to define many equations to calculate the optimization. Before I introduce the different algorithm to detect community, I want to introduce edge betweenness. Here it's just 3 pictures here. And first we got some vertex and we get the initial edge betweenness matrix. And we will first remove E45, then the E46 will have the biggest betweenness, it is 20. Then we get rid of the E46, and then E79 have the biggest betweenness 4, we also get rid of it. And gradually we just reach these final outcomes. Here we are. And so I will introduce Newman algorithm. Newman algorithm is the first method in community detection. The main feature of the algorithm of that its hierarchy and divisive. The major principle of this algorithm is to get rid of the links repeatedly according to their betweenness, which betweenness I introduced last pictures. And the way to calculate the betweenness is to see how many smallest paths with 2 verticals pass that specific link. To end the whole process is when the modularity reaches the biggest. And from these pictures, we can see the whole process end at these levels because it just reached the highest modularity. Fast-greedy algorithm. The reason we call it because it is the fast implementation of the Newman algorithm. The principle of the algorithm is that first we see each isolated node as a community and gradually combine the node together in order to get high modularity. The fast and greedy algorithm is modularity based. The whole process direction is totally different from the Newman algorithm. It is bottom up. And here we just begin from the single nodes and just go up and form some community. work trap algorithm. The main principle is that we define the distance between the two nodes is a random walk process. The basic idea is if there is a third node in the same community, then any other two nodes that will take the same random walk to reach that specific node. We could take the ij as two vertices in the community. The distance between these two vertices can be calculated by the equation below. Here, it's just the location of ig, and here is just the equation to calculate. And there is only one partition every time. We will get two communities based on the distance within them. And then these two communities will get a new partition, we will get a new community. The important process about a community is that in each step, we will get two communities together to get a small mean square distance between the two. Here is the result. We use Facebook network data to show the original picture without any community detection algorithm, which means without grouping. Here is the result for the Newman algorithm. We can see different colors represent different communities, also some basic information, verticals, edges, community detected. It's a result for the fast gradient algorithm, different color, different communities. Result for the work trap algorithm. Conclusion. After the community detection, because we use a real-world network data source, Facebook, so it is very hard to get a ground truth. We will use modularity to see which algorithm get performance better on community detection. The upper bound for the modularity is 1, but it can get very close. And when we calculate the modularity for different community detection algorithm, we found the fast gradient algorithm has the biggest modularity, and the work trap is second, then it's a Newman algorithm. So the fast gradient algorithm is better at detecting the community on the network data source we use in this project. Future work. In this project, I just use a single and limited network data source. In this specific data source, we can compare which algorithm has a better performance on community detection. But sometimes the data source will influence the algorithm performance. So in order to get a universal conclusions in the future, I will use diverse kinds of network source. Most likely the outcome is some algorithm is good at detecting community in this specific network, and some other algorithm is good at another networks. So in order to get a ground truth, we could use artificial networks, and we can define any kind of network we wanted, so we can better test the community detection algorithm. So thanks for watching.